Have you ever wondered how water flows as compared to honey? Is there a difference? Shall we take a look? Before I start the experiment, please remember to look at how it flows, not how fast it flows. That is, don't be distracted by the speed, but focus on the shape of the flow.
In this experiment, water will be colored blue for visualization purposes. Look at the shape of honey and water flow. By comparison, honey has a smooth shape while water has a rough shape. This is due to honey being more viscous than water. Viscosity is a measure of a fluid's resistance to deformation at a given speed. In this case, honey has greater resistance to deformation than water. This results in honey being in laminar flow while water is in turbulent flow. But what is laminar flow and what is turbulent flow?
Laminar flow is the flow of a fluid when particles follow smooth and orderly paths which are parallel to each other, and there is no swirling of fluids, as the paths do not mix and interfere with each other, but slide past adjacent paths like playing cards.
Yes, I defeated you!
Turbulent flow is the flow of a fluid when the particles are in a chaotic manner and the particles have no paths to follow to flow orderly. Fluids mix and swirl across the tube frequently, while pressure and flow velocity vary rapidly.
Oh no, how could I lose to you in this game? This game is so unfair!
Yup, that's definitely turbulent flow. But since we can't see honey and water particles using our naked eye, how do we then determine if a flow is laminar or turbulent?
Don't know?
Laminar and turbulent flow is calculated using a formula called Reynolds number. For a flowing fluid, when the Reynolds number goes below 2300, the more likely that the flow will be laminar. However, if it goes higher than 2900, it most likely becomes turbulent. When the number falls between 2300 and 2900, it is a transition flow. Based on this formula, the more viscous the fluid is, the more likely it is to be laminar. The less dense the fluid is or the slower it flows, the more likely it is to be laminar. The diameter of the tube the fluid is in also plays a part. When the diameter decreases, meaning the fluid passes through a smaller tube, the flow is more likely to be laminar. Why is it important for us to understand laminar and turbulent flow? American physicist Willis Whitfield invented the clean room to provide a sterilized workspace for experiments. It uses the concept of laminar flow to quickly and efficiently flush out impurities. If it had been turbulent flow, energy would be wasted pushing more clean air into the room to sterilize it. In air transport, we try our best to achieve laminar flow to minimize air resistance by building vehicles such that they have streamlined body shapes to enable them to go faster.
I hope that my presentation has helped you learn more about laminar and turbulent flow. See you!